In this lesson, we will look at how to instantiate a Revit family element, as well as how to control a family type and instance parameters in Dynamo for Revit. Since we will be automating the placement of Revit families and setting parameters, we need to create a new project file. We could go ahead and click on New and select the default template to continue. Once we're in Revit, we need to open the family that we're using for this exercise. Navigating to File, we can click on Open, browse to the datasets for this lesson, and click on the family titled column _ ComputationalLogic2.rfa. Click Open to open the column family. This Revit family contains a single column with various types. In order to explore the types, let's navigate to the Family Types dialog. This dialog can be found under the Create tab, Properties panel, and then the Family Types button. Launching the Family Types window, we can notice that this family has 3 different types loaded. Clicking on each type, we can notice that each type has a unique depth and width parameter as a type parameter. If we toggle through the types, we can see that this varies per type. We'll go ahead and click OK to close this dialog. In order to load this family into our active blank project, we can go ahead and click on Load into Project and Close within the ribbon. If you see a prompt to save changes to this family, go ahead and click No. We didn't make any changes to it at this time. Back in the Revit project, we are now in a Family Instance Placement mode. We can utilize this mode to view the type parameters of this family. Let's click on Edit Type in the Properties dialog. Within the Edit Type dialog, we can notice that we still have the 3 same types loaded into this project. Navigating between each type, we can see in the Dimensions category that we have a unique depth and width parameter as type parameters. And we can see that that's reflected in each of the types. Let's go ahead and select Type 1 and click OK and place a few instances of this family type to check them out. We'll place Type 1, switch to Type 2, and switch to Type 3. After we've placed one of each type, we'll go ahead and navigate to the default 3D view by clicking on the little house in the Quick Access toolbar. That's in the upper corner of your screen. Once we're in the 3D view, we can zoom in and see that the 3 column types do vary in their width and depth parameters. If we click on each type, we can see that each one is a unique different type. Another thing to keep in mind about Revit elements are the existence of instance parameters. Within the properties of each family instance, we have the ability to modify the height independently. This will come into play later on as we drive these elements in Dynamo. Let's go ahead and select these elements that we created and delete them for now. For the rest of this lesson, we will be using Dynamo to automate the placement of these family types based on their proximity to a point that we define. Columns closer to the point will be one size, while columns further away will be another size, and we'll be able to manipulate that live in Dynamo. Let's go ahead and navigate to the Manage tab and launch Dynamo. Once we have Dynamo open, let's maximize it to be able to see Dynamo as a full screen application. Once it's maximized, we'll click on New to start a new blank graph. Once you're in a blank graph, if your library is collapsed, go ahead and click on the arrow to expand it and then drag it so that way it's a little bit wider for us. In Dynamo, we're going to use a node called Family Types. Let's search for that in the library. Family Types is a node that is available in the Revit category. Clicking on this node in the library will place it on the canvas. With the node placed, we'll go ahead and move it to the upper left of our canvas and take a look at it. The Family Types node will look at the current Revit document and provide a selection of all of the family types available to us. Using the drop-down, let's navigate and find our loaded family. The family we loaded is ComputationalLogic2 type 1, 2, and 3. Let's select type 1 for now. In order to use all three types that we loaded, we need to have 3 family types selections in our canvas. Let's go ahead and copy this family types node 2 more times with a control drag copy. As a reminder, you can click on the family types node, hold down control, select the node again, drag to copy it. And we'll do this one more time. After we've copied the nodes, we're going to toggle the types to choose the other 2 types available to us. This would be column ComputationalLogic2 type 2 and column ComputationalLogic2 type 3. In order to use these family types, we need to merge them into a list or create a list of the family types. The way we can do this in Dynamo is using a list create node. Let's search for that node in the library now. Searching for the list create node, we can see that the option is in our list, and the definition of this node is makes a new list out of the given inputs. Click on the node in the library to place it on the canvas. With list create placed, we can go ahead and drag it to the right of our family types nodes and click on the plus sign to add extra inputs. The list create node is pretty unique because we can add and subtract inputs based on how many we need. In order to fulfill this node, let's tie the family types into the respective inputs. With those inputs fulfilled, we can hover over the list create node and see that we've created a list of 3 items. This includes all 3 family types of that specific family that we loaded into the Revit document. In order to access specific family types within this list, we need to use another node called getItemAtIndex. We'll go ahead and search for this in the library now. Searching for getItem will yield the result of getItemAtIndex in our list. If we click on it in the library, it will place on the canvas. Once we have the getItemAtIndex node placed, we can take a look at the input ports. On the list input, we simply need to input our list of elements that we want to extract an element from. On our index import, it takes an integer value, a whole number, so that way we can grab an item based on that integer. If we look back at our list create node and hover, we can see that we have 3 items in this list with indices of 0, 1, and 2. Let's go ahead and tie the output of our list create node into our getItemAtIndex node. And now, in order to select a specific family type from this list, let's use another node called integer slider. And once again, we'll search the library for this node. Typing in integer, we'll notice that integer slider is one of the options in our search. We'll click on the node in the library to place it on the canvas. Once we have the integer slider, we can drag it over to the left of our getItemAtIndex node. Plugging the output of our integer slider into the input of the getItemAtIndex input will fulfill this node. Once we have this node connected, let's place a watch node to see the output of it as well. And we'll search the library for watch. Once we have the watch node in the library, let's click on it to place it on the canvas. And we'll just drag this node up to the right of the getItemAtIndex and connect the output into the node. Watch nodes are really useful for having little viewers inside of your graph to be able to see what's going on at given moments. As we slide this integer slider, we can see that getItemAtIndex is updating dynamically. However, if you go over the number 2, it's currently going to an error state. If we hover over the node, we can look at some information that applies to this error. We'll move this watch node a little. The error is that the index was out of range. This means that we're asking the getItemAtIndex node to try to get an item that does not exist. If you remember, on the listCreate node, we have an index up to 2. In order to fix this, let's change our integer slider to have a maximum value of 2, which is the greatest item in our list. To do this, we can click on the drop-down of the integer slider and change the maximum to 2. With that process complete, you can see that our getItemAtIndex node has updated and the watch node displays the selected family type. We can go ahead and click this drop-down to close the integer slider options. Now that we're selecting a family type from our list, let's automate the placement of this in Revit. In order to do that, we can use a couple of other Revit-related nodes available to us in the library. If we go ahead and clear our search and navigate to Revit, Elements, Family Instance, since we're placing instances of a family type, we can find a node called ByPoint. Hovering on this node, you can see a description of it as well, but let's click on it and place it on the canvas. With this node placed, we can see that it has 2 inputs, one of which is a family type. In our watch node, you can see that we're extracting a family type from that list. Let's go ahead and fulfill that first input with the output of the getItemAtIndex node. As you can see, our other input is of type point, so it needs a point element to tell the family instance where to be placed. In order to do this, let's add a point by coordinate node to the workspace. Instead of navigating to the library on the left, let's right-click in a blank spot on the canvas. If you right-click in a blank spot on the canvas, we also have another search menu available to us. This menu is really helpful when you're searching for nodes that you've previously used and you know the name of. What we're going to do is search for point. Typing point, you should be able to get a few results that are in regards to points. We'll go ahead and place the point by coordinates node, the first one that pops up. With this node placed, we're going to go ahead and tile our Revit window next to our Dynamo window to see this actually create the Revit element live. So we'll just tile these side by side. With our Revit and Dynamo window tiled, I'll go ahead and make Dynamo a little bit wider and collapse my library for right now. So now we can go ahead and connect the output of the point by coordinates node into the family instance by point node. Once we fulfill that input, we'll notice that we have a column placed in Revit. Navigating to Revit, we can look at this and see that it's an actual Revit element of the generic model category, and we placed type 3 specifically. Opening Dynamo, if we slide our integer slider, we can see that this family type updates on the fly. This is an example of that parametric connection to Dynamo that Revit has. Keep in mind, we are running on automatic mode right now, and that's why these changes are happening live. In the bottom left corner, we can observe what mode we're running on. By default, Dynamo is running in automatic. Rather than one column, we'd like to have a whole grid of columns. So let's go ahead and build that logic into the Dynamo graph now. We'll go ahead and maximize the Dynamo window. So I mentioned that we want a grid of points. In order to achieve this, we need to change our point by coordinates node. If we zoom in on this node, we can see that it has default values currently of 0, 0, 0. We'd like to generate a range to be able to create these points. The way we're going to achieve this is through a code block. Double-click on the canvas for a code block. The values that we're going to enter are 0, dot, dot, number sign, 10, dot, dot, 12. Entering in this value into our code block, we're telling it to give us numbers that start at 0, count up by 12, 10 times. If we hover on our code block, we can see that as well. The output of this code block will go into the X and the Y coordinates of our point by coordinates node. And we'll move this node a little bit closer. I mentioned that we want a grid of points. Currently we have kind of an angle of points going on. In order to make this a grid of points, we need to work with lacing. So on our point by coordinates node, we can change the lacing by right-clicking on the node, navigating to lacing, and clicking cross product. Once we click cross product, we'll notice that we have a whole grid of points in the background preview of Dynamo. Additionally, if we minimize Dynamo or move it out of the way and navigate back to Revit, we'll notice that we have a whole grid of columns in Revit that are being created on the fly. Since Dynamo is still on Run Automatic mode and we still have the family instance by point node connected, we're able to create these elements as we make changes. Something to keep in mind. We'll re-maximize Dynamo. In order to pick and choose which of the family types are placed, we will need to create a point that will work as an attractor or a structural loading point to determine the distance and then place the type based on that proximity. To do this, we need to place another point by coordinates node. The easiest way of doing this would be to copy the one that we currently have. So we'll hold down Control and drag copy. With this node placed, let's disconnect the Y and the X inputs. What we can do for now is we have an X value of 0, a Y value of 0, and a Z value of 0. We'll just use the default values for now. This node will be our attractor point. So in order to determine the proximity of each of the points that are coming from our grid, we need to search for another node that's of use to us. So we can re-expand our library. I'll make it a little bit bigger, and we'll navigate to the top. We need to search for a node that calculates the distance to other geometry. So let's type in distance to in our library. Within our search results, we'll notice that we have a distance to node, and the description of this node is obtain the distance from this geometry to another. This node is exactly what we need, so we'll place it on the canvas. With this node placed, we'll drag it to the right of both of our point by coordinates nodes. For our first input of geometry, that would be our grid of points that we want to calculate the distance to the attractor point. So we'll connect that node to the points. For the other input, that would be our attractor point, so we could connect that now as well. If we hover on the geometry.distanceTo node and pin its output, we'll see that we have a series of values being calculated for us. These lists represent our columns of points in our grid. That's why we have series of 10. We defined 10 on our code block before our point by coordinates node that defines our grid. We can notice that the distance to node is returning values that are pretty large. These values need to correspond to the number of family types that we created in our list create node. If we hover over our list create, we'll notice that we have 3 family types. These family types have indices of 0, 1, and 2. So what we need to do is we need to effectively change these numbers based on another range of numbers. This process is called remapping the range. So what we can do is navigate to the library and search for another node that's of use to us. Searching for remap range, we'll see that we have a result that appears in math functions. And the description of this node is that it adjusts the range of a list of numbers while preserving the distribution ratio. Let's go ahead and place the remap range node. And we'll place it to the right of our geometry distance to node. Now that we have this node placed, let's hide the preview of the distance to node. The remap range node will take our current value and remap it within a target domain. In this case, our domain is 0 and the count of our family type list. This is because we have indices in that list of 0, 1, and 2. Since we want our remap range node to respond to that, we can go ahead and start fulfilling the inputs now. Our numbers will be the output of our distance to node. Our new minimum will be 0. Luckily, the remap range node has a default value of 0 already assigned to it. Our maximum value has a default value of 1 right now, which simply won't work for what we need. So in order to make this dynamic and tie together, we can actually count the number of items that we're creating in our list create node. In the library, let's search for a node called count. In our search results, we'll see that we have a count node that appears under the list category under inspect. Let's place that node on the canvas now. With this node placed, we'll place it kind of down below the distance to node, and we'll connect its input into our list create node. With this node connected, we can hover over the node and expand its preview to see that it's returning a value of 3. If you remember, we do have 3 items in our list create node, but they do end at an index of 2. This is because Dynamo is 0 indexed, so the index will always be 1 less than the total count. Let's go ahead and fix that with a code block. In order to make this work, what we're going to do is simply subtract 1 from the total count. Let's double click for a code block. We'll type count minus 1. As you can see, we now have an input for our code block. Let's tie in the output of the list.count node into our code block. With that connected, we can see that we're getting a value of 2. If we were to update the list create node by adding additional inputs, we'll see that this value updates on the fly. This is a good way of building Dynamo graphs because now they have some intelligence built into them. For now, we'll remove that additional input so that way we only have 3 family types. We'll move this math.remapRange node and plug the new maximum into the output of our code block. With this node connected, we can navigate to the right and view its output. Now we can see that we have values that start at 0 and end at 2, and they maintain their distribution between those values. Unfortunately, we're being supplied a value of double or number that has a decimal precision. Our indices on our getItemAtIndex node expects an integer. So what we need to do is turn these values into integers. The best way of doing this would be to simply round these down to the nearest whole number. Luckily, there's a node for that in Dynamo. So we'll go ahead and hide this preview and navigate to our library. Under the math category, we can navigate to functions and find a node called floor. The math.floor node will return the first integer smaller than the given number. So let's place that node on the canvas. With that node placed, we'll place it next to our remapRange node and connect the output of the remapRange into the input of the floor node. With that input fulfilled, we can expand its preview and see that we now have values between 0 and 2 that are whole numbers. This is really good because we can use this to retrieve a family type with the getItemAtIndex node. Let's go ahead and hide this preview and navigate back over to our getItemAtIndex node. Now that we're obtaining family types on the fly, we can go ahead and get rid of this watch node by right-clicking and clicking remove. We can also get rid of the integer slider. Once you get rid of the integer slider, you'll notice the family instance by point node goes into an error state, and that's because we're not giving it a family type quite yet. We can go ahead and ignore that error for now. In order to use our output of our math.floor node, let's move the getItemAtIndex node and the family instance by point node over to the right. Now that we have whole numbers coming from our math.floor node, we can plug this output into the getItemAtIndex's input for the index. For now, we'll go ahead and collapse our library so that we have a little more screen real estate, and we'll tile Dynamo next to Revit. With Dynamo tiled next to Revit, we can kind of zoom out and fulfill that input now. And we'll connect the math.floor output into the index input. With that input fulfilled, you'll see that in Revit, we've placed columns based on those values. If we look at the output of the getItemAtIndex node, we'll notice that we're obtaining family types based on those indices that were created from the distance to node. So now we have an attractor system implemented. If we were to navigate back to our attractor point and tie some values in, we can change that attractor point's location, effectively updating the columns. Additionally, if we click on the point by coordinates node, we'll notice that our attractor point gets highlighted in the background 3D preview of Dynamo. You'll notice that we have 3 arrows on that point. We have a green arrow, a red arrow, and a blue arrow. We can actually navigate to the background 3D preview with the node selected and start to manipulate this point. So we'll actually move this point around. And as we move it, you can see the preview in Revit moving as well. Another thing that you'll notice is the columns are updating dynamically. Once again, we're in a run automatic mode, so all of our columns are responding to the changes in Dynamo dynamically. We'll go ahead and switch back to the node canvas, and we'll see that we have two number sliders that were generated on our point by coordinates node. Since we were dragging the point around in the background 3D preview, it fulfilled those inputs for us. You can go ahead and drag these down and keep them for now. Currently, the logic in this graph is creating smaller columns the closer they are to the point. If we wanted to reverse this, that's very doable. Back before our list create node, we can switch our family types. So what we'll do is we'll flip these around. So now we flip these types to where it counts down 3, 2, 1, and now our logic has changed in Revit dynamically as well. This is really awesome because we're able to make these changes in Dynamo and see them instantly in Revit. Let's go ahead and look at a few other things that we can modify on these newly created columns. We'll expand our Dynamo window, and we'll go ahead and minimize it for now. Back in Revit, if we select one of these newly created Dynamo columns, or real Revit elements that we created, we'll notice that we have some parameters in the properties palette. These are instance parameters. We have a parameter of height that is unique to each instance. We could start to drive this parameter with Dynamo as well. Let's build out some logic to do this. In order to achieve this, we need to take note of the parameter name. This parameter name is height with a capital H. Parameters are case sensitive in Dynamo when you're working with Revit. We'll re-maximize Dynamo, and we'll go ahead and expand our library. So in order to make changes to these Revit elements parameters, we can set those parameters with Dynamo. So we'll search for a node called setParameterByName. Searching for setParameterByName, we can place this node. We notice that this node appears in the Revit bin as it's related to Revit elements. And we'll place this over next to our family instance by point node. As you can see, the setParameterByName node has three inputs. The first input requires an element. Our family instances that we're creating are elements, so we can plug that in to the output of the family instance by point. If we hover over parameter name, we can see that this value needs to be a string, and it would be the name of the parameter that we want to set. In our case, that parameter name is height. So let's look for a string node and place that now. With the string node placed, we can go ahead and move it a little bit closer to the workflow and type in height with a capital H. With that node fulfilled, let's plug its output into the parameter name. And we'll drag these nodes over so that way we can place another node to control this value. So since the height parameter requires a number input, we can use a slider to specify this value dynamically. So let's search the library for slider. We'll go ahead and select a number slider since it will produce numeric values that are decimals as well. With this node placed, we'll connect its output into the value input. Without even knowing it, we're making changes in Revit currently because we are on run automatically. So let's go ahead and tile Dynamo next to Revit to see these changes happening live. And once again, we'll collapse our library so that we have a little more space on our Dynamo window. And we'll tile the windows. With the windows tiled, let's go ahead and change the number slider and see what happens in Revit dynamically. Now as we drag the slider, the changes are happening live in Revit, which is really exciting because we're able to drive the family instances that we've created with Dynamo in the same Dynamo graph. As you can see, the definition that we just created efficiently automates the selection, placement, and parameter manipulation of a collection of Revit family elements.